Okay, for 5.1b, we're going to learn another vocabulary word. The word for 5.1b is function. The definition of function is a set of ordered pairs such that each x value matches to exactly one y value. So on the left, these are all going to be non-functions. On the right, these will all be functions, and I'm going to go through it and tell you why each one is not a function or a function. And that was the bell. Okay. This relationship is listed as ordered pairs. I'm going to check the x values and look for any repeated x values to see if they are corresponding incorrectly. So I have x is 1, 2, and 1. I saw that x was 1 twice. So right here I have 1, 3, and 1, 5. The reason this is not a function is because when x is 1, y is 3. When x is 1, y is also 5. So the same x value is matching to two different y values. And if you want to explain why, you can either say because x equals 1 has two different y values, or you can just list these two ordered pairs as proof that it is not a function. Okay, the next relation is represented as a table. Remember, I'm just going to look at the x values to see if there are any repeats. So in the x column, I have -2, 3, 4, -2. So the -2 repeated twice. Okay, this first ordered pair is -2, 1. The second one is -2, 4. So this is not a function because x equals -2 is matching to two different y values, 1 and 4. And you can either write x equals -2 as two different y values, or you can list -2, 1 and -2, 4 as proof that this is not a function. Okay, this last relation is represented as a mapping. Okay, I'm going to show you what it means first, and then I'll show you why it's not a function. Okay, when they're mapping it, they're showing that this 2 is mapping to 5, which means it represents the point 2, 5. Okay, so if I go to the next 3, 3 is mapping to 10, which is representing the ordered pair 3, 10. And then the 3 is also mapping to 15. This represents the point 3, 15. This is also the reason it is not a function, because the 3 is mapping to 10 and the 3 is mapping to 15. The same x value has two different assigned y values. Okay, let's go ahead and look at the ones that are functions so you can see how you would prove that they are in fact functions. Okay, the first one is listed as ordered pairs. If I check the x values, x is 3, 2, and 7. Because all the x values are different, then this is a function. And this is the reason I will give every single time. But this is also what I will check. So if it's given as a table, I'm still going to check the x column. If I check the x's, -2, 3, 4, and 6, this is a function because all x values are different. Okay, and then the third one is represented as a mapping. If you can read the mapping well, you can just tell from looking at it whether it is a function. I'm going to list the ordered pairs it represents because we have not used mappings very often. So at 0, this is mapping to 7, so 0, 7. 3 maps to 5. 2 maps to -3. 5 maps to 10. And 6 is matching to 1. Okay, now if I look at the ordered pairs represented here, all the x values are different, which is why this is a function. Okay, the last thing for this section is what we call the vertical line test. This is how to test whether a given graph is a function or not. It's called the vertical line test, so we're going to use a vertical line reminder. Vertical line is the line that goes in this direction. Okay, so if a vertical line can be drawn that intersects a graph more than once, then the graph is not a function. And I'm going to show you what I mean on the first one. So this is the graph right here. I want to try to draw a vertical line that will intersect the graph more than once with the same line to show it's not a function. So if I were to draw a vertical line here, it will intersect the graph here and here. Because the same vertical line can intersect the graph at more than one spot, this makes it not a function. Okay, so I'm gonna go ahead and try the next one. The graph of this one is a circle. I'm gonna draw a vertical line and I wanna try to see if I can make that same vertical line intersect the graph more than once with the same line. So let's see, so for example, if I drew it here, that one vertical line intersects the graph once, twice, meaning this is not a function. Okay, I'm gonna go ahead and look at this graph here. It's a polynomial function. Okay, I wanna see if there's a vertical line I can draw that will hit this, intersect this graph more than once. So if I drew it here, that would only hit once, only once, only once, only once. I don't see any place I could draw a vertical line where it will intersect the graph more than once with the same line, so this is a function. Okay, let me check this line down here. Okay, let's see, if I drew a vertical line here, it would only intersect once. If I do it here, it only intersects once, once. I don't see any location I can intersect the graph multiple times with the same vertical line, so this is a function. Okay, let's go ahead and list it, look at these ordered pairs. Okay, let's see. If I drew it here, I'll hit once, once. Oh, if I draw the line right here, then I can intersect the graph at 1, 2, 3 points, which means this is definitely not a function. Okay, let me check this last one. If I draw it here, here. No, there's no place I can draw a vertical line where I can intersect more than once, so this has to be a function. Okay, so go ahead and try the practice problems and then check your answers from the calendar.